Hey y'all, I'm going to create 4 videos out of this. I think it's just going to be easier so it's not obnoxiously long. Let's just start with 7.1 and there'll be a video for each section that we're covering for the exam. So the first one is convert the angle. We've got a couple of angles here. One is 240 degrees. We're going to convert it to radians, and then we're going to do the radians to degrees. So the first one is 240 degrees to radians. So A is 240 degrees. And anytime you're converting degrees to radians, you want to multiply by pi over 180 degrees. That itself will do it. Now, to make sure that you get the most points you can, please make sure that you reduce. So I'm going to go ahead and rewrite this. 240 pi over 180. Please note that the degrees are gone. Do not represent degrees if you're now in radians. And then now I'm just going to reduce. I know that these two will make it go away, and then I've got 24 over 18. Well, 6 goes into 24 and 18. So I'm going to start dividing both by 6. 24 divided by 6 is 4, and 18 divided by 6 is 3. And don't forget your pi. So there is your radians from degrees of 240. The next one is B. Now this one, I showed you a really cool thing that I did, the way I learned this in high school, and that is where the pi symbol is. I just replaced that with 180. But the real concept, if you're going from radians to degrees, is to multiply by 180 degrees over pi. Now, it means the same thing because this goes away, and now you've got negative 5 times 180 over 6. So negative 5 times 180, I'm just going to whip out my calculator here. Negative 5 times 180, that's negative 900 divided by 6 is negative 150 degrees. Please make sure and represent your degree symbol to show that. Find 2 positive and 2 negative angles coterminal with 45 degrees. Well, coterminal just means they share the same terminal side. Remember, if this is always the initial side for your angle, initial side, then this is going to be our terminal. So we want to know, looks like 2 positive and 2 negative that have the same, end up in the same place as our 45 degree angle does. Now, I'm going to start with the positives because all I need to do is go a full rotation, end up back on the same terminal side, and bada bing, bada boom, I'm there. So 45 degrees plus 360 is going to give me a full rotation that ends up back on the same terminal side. So 405 degrees is one of the positives. I mean, there's an unlimited number of answers here. I'm just doing the one. And then I can do another full rotation. So 405 plus 360 will give me another positive angle. Okay. Now to get 2 negative angles, I'm going to start from here and go around. Well, that would be 45 degrees minus 360. I'm going to whip out my calculator for this one. So that would be negative 315 degrees. And that just means I went from this part around to here to end up on the terminal side. If I want another negative, I just need to go with another negative 360. So negative 375 degrees. So those are my 2 negatives that I'm choosing to use and my 2 positives. Sketch an angle of a negative 120 degrees in standard position. All right, identify the quadrant of its terminal side. Now, if you think about what 120 degrees looks like, typical 120 degrees, and I want a pencil for this because we're not referencing 120 degrees, but I want you to see the distance it is around. So that would be 120 degrees, okay? But we're not going 120, we're going negative 120 degrees. So it's going to be the mirror image across. So instead of going this way, we're going to go down. We're going to go clockwise. So there is our negative 120 degrees. There's our angle for that. Standard position, yep, there's my initial and my terminal sides. Identify the quadrant of its terminal side. So you need to know what your quadrants are for this exam as well as the final. And there's your quadrants. This angle, negative 120 degrees, is in quadrant 3. And it is done in Roman numerals. All right, let's go to the next one. Find the length of the arc intercepted by a central angle, theta, 3 pi over 4, and a circle of radius r is equal to 10 meters. Round to 2 decimal places. Well, you need to have your angle in radians when you do this. So if I give you the angle in degrees, please be careful, because when you are looking for the length of the arc, it needs to be, this angle needs to be in radians, and it currently is, which is fantastic. And anytime I'm looking for the arc length, that is S, which is your arc length, is equal to your radius times your angle, radius times theta. And again, theta must be in radians. So my arc length is going to be 10 times 3 pi over 4. And I'm going to put this in a calculator. 10 times 3 pi divided by 4 equals, and that's 23 point, what am I rounding to? 2 decimal places. 23.56. Now that is not my full answer. Please be careful, because this needs to have a unit with it. You're measuring the arc length, so it needs to have the same unit as your radius. Okay. Most people forget this one in the exam. Make sure you have this written on your note card. A Ferris wheel rotates 7 pi over 3. Okay. How many complete revolutions is this? What is the coterminal angle between 0 and 2 pi? All right, so remember 2 pi is a full rotation. I know many of you are struggling with the radians, so let's just change this to degrees. Let's just change it to degrees. Find your coterminal angle, and then you can change it back to radians. Your answers need to be in radians. All right, so take 7, I'm going to multiply it times 180 degrees, and divide that by 3 to find my radians to degrees. And that is 420 degrees. It's easier to see now that this is more than a full rotation, okay, because a full rotation is 360 degrees. So it says, how many complete revolutions is this? This is, because it's a question, this is 1 complete revolution. It's more than that, but it's for complete, that's the word we're looking for. It is 1 complete revolution. What is the coterminal angle? Well, what does this look like? What is this angle? I'm going to subtract 360 from this so that I can find out which angle it is. This is 60-degree angle. So if you're thinking about what this guy looked like, this is, give me just a moment, 6, 7, 8, there. So the 420 degrees, or the 7 pi over 3, is actually this angle here. That is 7 pi over 3. I have just found that we are ending up at 60 degrees, right? That is a coterminal angle between 0 pi and 2 pi. The only thing I need to do with that 60 degrees is change it to radians. So to change a degree to radians, that's 60 degrees times pi over 180 degrees. So that's 60 pi over 180, and you just need to reduce it now. Do not leave it in this format. The zeros are gone. We're left with 6 pi over 18. Those are both divisible by 6. 6 divided by 6 is just 1, so that leaves me with pi in the numerator. 18 divided by 6 is 3. So pi over 3 is my coterminal angle. ends on the same terminal side. That's what that means. Right triangle trigonometry. In a right triangle, the acute angle is 38 degrees and the adjacent side is 12 feet. All right, I need to draw this because I can't just picture it. Here's my right angle. Acute angle is 38 degrees. The adjacent side, which is this one here, is 12 feet. This is my opposite side. This is my hypotenuse. Find the opposite side. Round to 2 decimal places. Create a sentence. You can only use sine, cosine, and tangent, and make sure your answer is you're using degrees. Okay. Well, that's easy enough. So if we have the adjacent side and we need the opposite side, you've got to think of what you have here. You have sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. So out of these three, since these are the three I'm recommending, the only ones I want you to use, you're going to want to use tangent because it has opposite and adjacent. So we're going to use tangent of 38 degrees is equal to the opposite side that we're looking for. Please know that's not 0, that's O for opposite. And then my adjacent side is 12. Now to solve for my opposite side, I just need to multiply both sides by 12. And I get 12 tangent of 38. Make sure your calculator is in degrees, not radians. Okay, I think mine's in radians. Nope, it's in degrees. Fantastic. So I'm going to put 12 times tangent 38 equals. And I got 9.375. And I need to round to 2 decimal places. So I'm going to write this, 9.375. Because I want you to see the rounding. If this is my rounding digit, the number next to it on the right is my test digit. Because my test digit is 5 or greater, it is 5, I add 1. Don't use the words round up. It's not mathematical. Add 1 to your rounding digit. So this means the opposite side, I need a sentence, is 9.38. What's my unit? I know I have a unit here and it is feet. You want to represent the correct unit for this side. All right. A ladder leaning against a wall makes 63-degree angle with the ground. So here's a building. And you got a ladder leaning against the wall. And it says the ladder leaning against a wall makes a 63-degree angle with the ground. Well, here's the ground. So that means this angle is 63 degrees. If the ladder is 17.82 feet up the wall, so that's this one here, how long is the ladder? So this is what we're looking for. Okay, so what is this 17.82 compared to the angle? This is the opposite side. Okay, this is our opposite side. The ladder is directly across from the right angle that was created, and so that means it is our hypotenuse. So we're looking for the hypotenuse here. It says to round to the whole number, create a sentence, only use sine, cosine, and tangent, and make sure your calculator is in degrees. If I gave you an angle in radians, you would use radians. Okay? So we need to know, again, coming back to these three, which one has opposite and hypotenuse? Well, that would be sine. So I'm going to use sine of the angle is equal to, the opposite is what we're looking for. The hypotenuse, oh, nope, sorry about that, y'all. I'll just go ahead and do this. Let's try again. I'll get there. The opposite is 17.82. Oh, so sorry. It's my alarm to wake up. All right. And then over hypotenuse, which is what we're looking for. Now this one's different from this one. This one's a little easier to solve. This one you're going to have to multiply both sides by h. All right, that makes this part, we wanted hypotenuse up in the numerator. And now we're going to, I'm going to rewrite it, h sine of 63 degrees is equal to 17.82. Now we're going to divide both sides by sine of 63 degrees. All right, so this is what we're going to put in our calculator. Make sure your calculator is in degrees. 17.82 divided by sine of 63, and that is 19.99999. So we're rounding to the whole number. I did that on purpose because it is 20. So the ladder is, how long is the ladder? The ladder is 20, and it's feet long. All right. A kite string is 85 feet long and makes a 27-degree angle with the ground. Let's get drawing. So we've got a kite string is 85 feet long. That doesn't work for me. Where is it standing? The kite becomes stuck in a tree. Okay, so here's my tree. Kite becomes stuck in a tree. All right. Here's my string. And it's 85 feet. This kite string makes a 27-degree angle with the ground. So that means this angle is 27 degrees from where I was standing. The kite became stuck in a tree. Here's my tree. How far was I standing from the base of the tree? So I am looking for, if this is where I'm standing, right here, and this is the base of the tree, we want to know what this location, what this distance is here. And this, compared to the angle, is the adjacent side. This is the opposite side. And of course this is the hypotenuse. Okay, so again, we only want to use sine, cosine, tangent. We want to make sure our calculator's in degrees. We want to provide a sentence, and we want to round to 2 decimal places. I'm not going to provide you all this. This is hints for you to help with the review. I'll tell you what to round to, but I'm not going to remind you to write a sentence, which functions to use, and to make sure your calculator's in degrees. This is things you need to know. All right, so I need to know which trig function I can use between sine, cosine, and tangent that has adjacent and hypotenuse. And that's going to be cosine. It has adjacent and hypotenuse. So cosine of theta is adjacent over hypotenuse. Now let's fill it in. Cosine of 27 degrees. The adjacent side is what we're looking for. And the hypotenuse is 85. So this is an easy one. Multiply both sides by 85. And the adjacent side is 85 times cosine of 27 degrees. And that is 75.735. We're rounding again to 2 decimal places, so this is my rounding digit. This is my test digit. Because it is 5 or greater, I add 1 to my rounding digit. So let's writing our sentence. How far was I standing? I was standing, or you were standing. Either one. I was standing. 75.74. The unit is feet from the base of the tree. I'm using the words base of the tree. From the base of the tree. Just answer the question. That's what we're looking for. Alright, the last one for this video is going to be in a right triangle. Side lengths are opposite, hypotenuse, reduce fractions, no decimals. Find sine, cosine, and tangent. Okay, so I'm going to go ahead and draw my right triangle. This will be my theta. Alright. This is going to be my opposite, my hypotenuse, and my adjacent. It says the opposite side is 9 inches. The hypotenuse is 15 inches. We need to know what the adjacent side is so that we can find cosine and tangent. Well, do we? Okay. Actually, we've got so many different ways we can do this, but let's go ahead and do it this way. So I can find sine right now, but I want to go ahead and find my adjacent so that I have that. A squared plus b squared is equal to c squared. Your hypotenuse, if it's easier to write it opposite squared plus adjacent squared is equal to hypotenuse squared, that's what's happening here. That's what we're doing. So the opposite is 9. We're looking for our adjacent, and our hypotenuse is 15. And we just need to solve for A. 9 squared is 81. 15 squared is 225. Subtract 81 from both sides. We get A squared is equal to 144. Fantastic. Take the square root of both sides. Normally we would put plus or minus here. You can't measure distance in negative, so we're just going to leave it as the adjacent side is equal to 12. So 12 inches. All right. Now we're going to find the sine, cosine, and tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So A, sine of theta, is 9 over 15. We want to reduce that. They're both divisible by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. So there's my sine. There's your sine. Cosine is adjacent over hypotenuse. Adjacent is 12. Hypotenuse is 15. These are both divisible by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. There's my reduced cosine. And then tangent of theta is opposite 9 over adjacent 12. Both divisible by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. There is my tangent. Alright, that's it for this video. See you in the next one.